Have you ever seen a student make this mistake when working with logarithms? Many students think that the logarithm of 3 to the fourth power equals the logarithm of 3, all raised to the fourth power. This is completely incorrect. The correct way to handle this expression uses the power rule of logarithms. Watch how the exponent moves to the front as a multiplier. This transformation follows the power rule of logarithms, which states that the logarithm of m to the nth power equals n times the logarithm of m. In this video, you'll master this powerful rule step by step. We'll explore why it works, how to apply it correctly, and solve 3 progressively challenging examples that will build your confidence with logarithmic expressions. By the end of this video, you'll confidently manipulate logarithmic expressions and avoid the common mistakes that trip up many students. Are you ready to unlock the secrets of the power rule? The power rule of logarithms is one of the most useful tools for simplifying logarithmic expressions. Understanding this rule will make working with logarithms much easier and more intuitive. The power rule states that the logarithm of a number raised to an exponent equals the product of that exponent and the logarithm of the base number. Mathematically, we write this as log base a of m to the n equals n times log base a of m. Let me break down each component of this formula. The letter a represents the base of the logarithm, m is the number inside the logarithm, and n is the exponent that we're working with. Now that we understand the components, it's important to know the restrictions that apply to this rule. There are important restrictions we must remember. The base a must be positive and cannot equal 1 because logarithms with base 1 are undefined. Additionally, the number m must be positive, since logarithms of negative numbers are not defined in the real number system. Now let me show you visually how this rule works with a simple example. Here's a concrete example. If we have log base 2 of 8 to the third power, the power rule tells us we can move that exponent 3 to the front as a multiplier, giving us 3 times log base 2 of 8. The key insight to remember is that exponents inside logarithms become multipliers outside. This transformation is what makes the power rule so powerful for simplifying complex logarithmic expressions. So remember, the power rule of logarithms states that log base a of m to the n equals n times log base a of m. This fundamental rule will be essential as we explore more complex applications in the following sections. To truly understand the power rule of logarithms, we need to go back to the fundamental meaning of what a logarithm actually represents. A logarithm is fundamentally asking a question. When we write log base a of m, we're asking, to what power must we raise a to get m? Now let's consider what happens when we have log base a of m to the power n. This is asking the same fundamental question, but now about m raised to the nth power. The key insight is understanding what m to the power n actually means. M to the power n is simply m multiplied by itself n times. So when we have log base a of m to the power n, we can rewrite this as log base a of m, repeated n times. Now we can use the product rule of logarithms. The product rule states that the logarithm of a product equals the sum of the logarithms. Using the product rule, we can expand our logarithm of the product into a sum of individual logarithms. When we add the same term to itself n times, this is simply n times that term. So we get n times log base a of m, which is exactly the power rule. This shows us that the power rule is not just a formula to memorize, but a natural consequence of how logarithms and exponents work together. The power rule emerges directly from the fundamental properties of logarithms. Now that we understand what the power rule is and why it works, let's apply it step by step to a concrete example. We'll work through this systematically so you can see exactly how to use this rule. Here's our example. Log base 2 of 8 to the 16th power. This looks complicated, but the power rule will make it much simpler. Let's break this down into clear, manageable steps. Step 1. We need to identify the 3 key components in our logarithmic expression. First, we identify the base of the logarithm, which is a equals 2. Next, we identify m, which is the number inside the logarithm before the exponent. Here, m equals 8. Finally, we identify the exponent n, which is the power that m is raised to. In our case, n equals 16. Now that we've identified all our components, let's move to step 2, where we apply the power rule formula. Step 2. Now we apply the power rule. According to the rule, log base a of m to the n equals n times log base a of m. so our expression becomes 16 times log base 2 of 8. Notice how the exponent 16 has moved from inside the logarithm to the front as a multiplier. This is exactly what the power rule allows us to do. Now we need to simplify this expression. Let's move to step 3. Step 3. We need to simplify log base 2 of 8. To do this, we ask ourselves, what power of 2 gives us 8? We know that 2 to the third power equals 8. Let me show you. 2 times 2 times 2 equals 8. Therefore, log base 2 of 8 equals 3. This is because the logarithm asks, to what power must we raise 2 to get 8? The answer is 3. Now we can substitute this value back into our expression and complete the calculation. Step 4. Now we substitute our result. We have 16 times log base 2 of 8, which becomes 16 times 3. 16 times 3 equals 48, so our final answer is 48. Therefore, log base 2 of 8 to the 16th power equals 48. The power rule transformed a complex-looking expression into a simple multiplication problem. This demonstrates the power and elegance of the power rule. What seemed like a difficult calculation became straightforward once we applied the rules systematically. In our next section, we'll work through more examples to build your confidence with this technique. Now let's work through our first example to see the power rule in action. We'll simplify a logarithmic expression step by step. Our problem is to simplify log base 5 of 25 to the third power. This is a perfect example for applying the power rule. First, let's identify the components of our logarithmic expression. The base a equals 5, the number m equals 25, and the exponent n equals 3. Now we apply the power rule. Remember, the power rule states that log base a of m to the n equals n times log base a of m. Applying this rule to our expression, log base 5 of 25 to the third power becomes 3 times log base 5 of 25. Next, we need to evaluate log base 5 of 25. Let's think about this step by step. We need to find what power of 5 gives us 25. Let's check. 5 squared equals 25. Therefore, log base 5 of 25 equals 2. Now we can complete our final calculation. We substitute our result. 3 times log base 5 of 25 becomes 3 times 2. And 3 times 2 equals 6. So our final answer is 6. To summarize, log base 5 of 25 to the third power simplifies to 6. This demonstrates how the power rule can make complex logarithmic expressions much easier to evaluate. This was a straightforward application of the power rule. In our next example, we'll see how this rule helps us solve more complex exponential equations. Now we'll tackle a more challenging problem. We need to solve the exponential equation 2 to the power of x equals 32. This type of equation appears frequently in algebra and requires us to use logarithms strategically. The key strategy for solving exponential equations is to take the logarithm of both sides. This allows us to bring the exponent down using the power rule, making the equation much easier to solve. Step 1. We take the common logarithm, base 10, of both sides of the equation. This gives us log of 2 to the x equals log of 32. Notice that we're applying the logarithm to the entire expression on each side. Step 2. Now we apply the power rule of logarithms to the left side. Remember, the power rule states that log of m to the n equals n times log of m. So log of 2 to the x becomes x times log of 2. Step 3. To isolate x, we need to divide both sides by log of 2. This gives us x equals log of 32 divided by log of 2. We're using the division property of equality here. Step 4. Now we need to calculate the numerical values. Using a calculator, we find that log of 32 is approximately 1.505 and log of 2 is approximately 0.301. Let me show you these calculations step by step. Step 5. Finally, we divide 1.505 by 0.301 to get approximately 5. Therefore, x equals 5. We can verify this is correct because 2 to the 5th power equals 32. To summarize our solution, we started with 2 to the x equals 32, took logarithms of both sides, applied the power rule to bring down the exponent, isolated x, and calculated the final answer. The solution is x equals 5. Now we'll explore a fascinating real-world application of the power rule of logarithms in chemistry. We're going to calculate the pH of a solution, which is crucial for understanding acidity and alkalinity in everything from swimming pools to our own blood. The pH of a solution is calculated using this logarithmic formula. pH equals the negative logarithm base 10 of the hydrogen ion concentration. This formula is fundamental in chemistry because it helps us measure how acidic or basic a solution is. We're given that the hydrogen ion concentration is 10 to the negative 7 molar. This is actually the concentration of pure water at room temperature, which means we're calculating the pH of neutral water. Step 1. We substitute our given hydrogen ion concentration into the pH formula. So pH equals negative log base 10 of 10 to the negative 7. Step 2. Now we apply the power rule of logarithms. Remember, log of m to the n equals n times log of m. So log base 10 of 10 to the negative 7 becomes negative 7 times log base 10 of 10. Step 3. We need to evaluate log base 10 of 10. Since 10 to the first power equals 10, log base 10 of 10 equals 1. So our equation becomes pH equals negative times negative 7 times 1. Step 4. Now we simplify. Negative times negative 7 equals positive 7, therefore the pH equals 7. This result has important real-world meaning. A pH of 7 indicates that our solution is perfectly neutral, neither acidic nor basic. This is exactly what we expect for pure water at room temperature. The power rule helped us quickly calculate this fundamental chemistry value. This example perfectly demonstrates how the power rule of logarithms transforms complex real-world calculations into simple arithmetic. Without the power rule, calculating pH values would be much more difficult and time-consuming. We've covered a lot of ground in this video, so let's take a moment to recap the key concepts and see what you should focus on next. The heart of everything we've learned is the power rule of logarithms. This fundamental rule states that the logarithm of a number raised to an exponent equals the exponent times the logarithm of that number. Throughout this video, we explored 3 main applications of the power rule, each building on the previous one to show you the versatility of this mathematical tool. First, we learned how to use the power rule to simplify logarithmic expressions. By moving exponents outside the logarithm, we can transform complex expressions into much simpler calculations. Second, we discovered how the power rule helps us solve exponential equations by converting them into linear equations that are much easier to work with. Finally, we explored real-world applications, specifically pH calculations in chemistry, showing how the power rule connects abstract mathematics to practical scientific problems. As you continue practicing with the power rule, remember these important conditions and limitations that ensure you apply it correctly every time. The base must be positive and not equal to 1. The argument inside the logarithm must be positive. The power rule only works when the entire argument is raised to a power, not just part of it. And always check your domain restrictions before applying the rule. Now it's your turn to master this concept. The best way to truly understand the power rule is through practice with a variety of problems. Start by practicing with different bases and exponents to build your confidence. Then try combining the power rule with other logarithm properties like the product and quotient rules. Finally, challenge yourself with real-world application problems from science and engineering. If this video helped you understand the power rule of logarithms, please give it a thumbs up and subscribe for more mathematics tutorials. Your support helps us create more content like this. Don't hesitate to ask questions in the comments below. I read every single one and love helping students work through challenging problems. Also, let me know what mathematical topics you'd like to see covered in future videos. Remember, mathematics is a journey of discovery, and every expert was once a beginner. Keep practicing, stay curious, and I'll see you in the next video where we'll explore even more fascinating mathematical concepts together.